This problem is bound to be more involved than the last one that I worked, and I've never done this one before. I just made it up, so we'll see how it goes. Um, don't get too hung up with the the square root that may appear in here or some of the algebra. What I really want you to concentrate most on is how we form a function with a single variable, because as it turns out, this problem has really two variables in it to begin with, and we have to eliminate one of those variables in order to create a function with a single variable. So let's get started and you'll see what I mean. Alright, I'm going to read the problem. A trapezoid is formed by placing a right triangle atop a square. If the area of the trapezoid is 100 square inches, write the function describing perimeter in terms of the base. Alright, now let's draw our trapezoid, and we have this square, and suppose I let x be the base of the square. And in fact, I'm going to describe the perimeter in terms of x. So we'll end up with a function of x when we get done. And then we put a right triangle over it, and that forms the trapezoid. Now, when we go to calculate the perimeter, we won't include this part of it, because the perimeter is the outside of the trapezoid. So I won't be including that, but I'll keep that in there, just at least for now. Now, what else shall we say here? Suppose that this part we added has a height of y. So here's x again. Here's y. And there we go. Now, the perimeter, we can write a function for perimeter right now if we want to. After first figuring out the diagonal. Now, the diagonal length we would find by using the Pythagorean theorem. And just to recap that, review it for you. Suppose this is L for length. The Pythagorean theorem says as a right triangle, we have x squared plus y squared equals to L squared. So that means the length would be the square root of x squared plus y squared. Alright, so I'm going to write square root x squared plus y squared there. And then erase this stuff. So we can go ahead and describe the perimeter, and we should. The perimeter will be, and again, we're not going to add up this side into it, but we have 3x's plus y plus that square root. So it's going to be 3x plus y plus square root of x squared plus y squared. Alright, now we're not done because we want perimeter in terms of the base. In other words, in terms of a single variable. And the reason for this is very practical. That if we turn this into a calculus problem, in order to optimize it, it is a lot easier to optimize a function when it's a function of a single variable. There are techniques for optimizing functions of two or more variables. Like this, for example, right now it's written as a function with two variables, x and y in it. And those calculus optimization techniques aren't studied until like a fourth quarter of calculus. And they really are, as you might expect, a bit more complicated. So if we can write a function with a single variable, then that carries a big advantage as far as studying it and analyzing it. Alright, well, so how are we going to get rid of the y variable, which is what I'm asking. I want to write the function without y. How in the world are we going to do that? And I think this is a point that nails students in this section, because in order to get rid of y here, I have to find another expression or another equation using x and y. And where might that come? Well, have I used all my information yet? No, because the area of the trapezoid is 100 square inches. Alright, so let's investigate that. Now, area of the trapezoid is going to be what? The area. And let's see, I'll write it down here. Area. would be the area of the square, which would be x times x, or x squared, plus an area of a triangle is 1/2 base times height. It's very easy to see that because if I took this triangle and just stuck another copy on top, I'd have a little rectangle. And that area is x times y, so half of that will be my triangle. So 1/2 x times y. And the area we know is equal to 100 square inches. So what this does for us, it allows us to calculate y in terms of x. In other words, solve for y. And I'm going to do that. I'm going to first subtract x squared. So I have 1/2 xy equals to 100 minus x squared. And then I'm going to multiply everything times 2. That cancels the 1/2 on the left side. So I have x times y equals to 200 minus 2x squared. Well, I'll tell you what, let me just keep it factored. 200 parentheses 100 minus x squared. And now I finish solving for y by dividing by both sides by x here. X's cancel, and there's my expression for y. So I know that y equals to 2 parentheses 100 minus x squared all over x. Alright, now that's the missing ingredient, because if I'm going to write this with a single variable x, I've got to figure out what to do with y. And I can substitute this expression for y, which is in terms of x. So the perimeter, and make sure I got everything I need before I erase. I don't have quite enough board space to do this problem like I'd like to, so it's a little bit more crowded than it should be.